Is there meaning in the universe, purpose in life? I care about meaning and purpose, so I often explore origins. Did the universe begin? If so, how so? Can science explain it all naturally, or is something supernatural required? Another way to address meaning and purpose is by exploring destinies. Will the universe end? If so, how so? If not, why not? I yearn to know whether the universe will end, irrespective of meaning and purpose. The sheer majesty of human thought, venturing trillions of years into the future. Will the universe ever end? I'm Robert Lawrence Kuhn, and Closer to Truth is my journey to find out. What would it mean for the universe to end? Disturbance, disruption, disintegration, disappearance? And what actually would end? How could all that exists, a vast universe of 100 billion galaxies, many with hundreds of billions of stars and planets, just cease to exist? I begin with a theoretical physicist who uses fundamental laws to explain how the cosmos works, from subatomic particles to the grand structure of the universe. Michio Kaku.
Michio, what can we say today about what the far future of our whole universe really will be?
Philosophers and poets have asked the question, will the world end in fire or ice?
Right.
We can now give an answer. The universe, we think, will die in ice. Our Earth will probably die in fire, probably be eaten up by the sun as it dies. Our Milky Way galaxy will probably die in fire as it collides with Andromeda, a nearby galaxy, and gets eaten alive by our closest galactic neighbor. The latest evidence shows that the universe is not slowing down, but it's speeding up out of control, and that we will probably all die in ice trillions upon trillions of years from now.
And what happens to the particles in our universe as the universe acceleration speeds up and gets faster and faster? All the particles just get more and more dispersed from each other.
That's right, and the night sky will be unrecognizable in the future. The galaxies will be so far away that light cannot even reach us anymore. And it's going to be quite dark at night as the suns blink out in outer space. The universe seems to evolve in 5 basic stages. The first stage was the fiery Big Bang and the creation of the early stars. We're in the second stage, a very early stage, the stage of star formation. But on a large scale of things, life and star formation is just the very first 2 stages. Then we go into a much larger stage where the stars begin to die. Red dwarf stars begin to dominate the universe. Then black holes. All of a sudden, all the stars are gone in the future. They're nothing but dead neutron stars. We have black holes that are dying embers of these gigantic objects that once flared up in the universe. Even beyond that, atoms themselves begin to disintegrate. The proton, which is the bedrock of our existence, everything we see and touch is made out of protons, they begin to disintegrate. And in the far future, everything becomes a gas of electrons, a gas of neutrinos, and temperatures are so low that no machine can possibly create any motion in this distant future. In other words, the laws of physics are a death warrant to all intelligent life.
So what does that mean? I mean, how do we reflect upon that? Everything seems so normal.
Well, the job of us physicists is to calculate the engine driving this runaway expansion of the universe. It seems to be something called the cosmological constant, the dark energy, the energy of nothing. Nothing, believe it or not, the vacuum of outer space is a storehouse of energy that's pushing the galaxies apart. We have looked for the engine driving this expansion, and some people have looked for alternative cosmologies. There is a theory called the Big Splat theory, where our universe is a membrane, this gigantic beach ball, which collides with another beach ball. And the collision could be periodic, and each collision creates a big bang of sorts.
Every trillion years or so.
Right. So in that universe, perhaps we can start all over again, but it does mean there's going to be a fiery big crunch where everything we see around us will be in flames. So, you know, we have a choice, either be burned alive in fire or frozen in ice. But either one seems to be a logical conclusion of the equations. It seems to be unavoidable. I think there's a shelf full of...
That's it? That's the story, the whole story? Fire or ice, and we get the ice? Unavoidable, says Michio, according to the laws of physics. But why so certain? After only a few hundred years of modern science, and barely a century of scientific cosmology? I'd want there to be more. The story's too short, the vision too simple. What's the rationale behind the fire and the ice? Why the fire? Why the ice? I go to MIT to visit a cosmologist who explores frontiers of knowledge, Max Tegmark. Fire or ice, Max? Big crunch or big chill?
When I was first taught this stuff in graduate school, there were two futures. Either there's the big chill, things expand forever, or there's the big crunch. And to figure out, all you needed to do is measure how much stuff there was and see if its gravitational pull would be strong enough to reverse the expansion. Right? Suddenly, dark energy burst on the scene, right? It started to begin to look like there was not enough stuff to reverse the expansion, and we were going for the big chill. Now it turned out that that didn't matter anymore, because dark energy now makes up 3/4 of the universe, and it refuses to dilute. It's this really weird stuff that has the property that if you put it into twice the volume, the density is still the same. So there's now twice as much mass there.
So it seems to be energy literally of empty space.
Exactly, and the fact that it doesn't dilute while all the other stuff dilutes means eventually it takes over. And the whole future of the universe depends on what this stuff is. If the stuff stays constant, like Einstein's cosmological constant idea,
right,
then the future is the big chill, expansion forever. On the other hand, if this stuff actually does dilute a little bit and eventually goes negative, you actually get a big crunch. So the big crunch is back in the cards. And the third possibility is that it actually anti-dilutes. You get an even higher density of this stuff when it stretches out, in which case you get a big rip, where a finite time from now, the density of this stuff actually becomes infinite. The universe expands so fast that it even rips apart the solar system, and then rips apart the planet, and rips apart the atoms we're made of. So now it's big chill, big crunch, or big rip, and it all comes down to understanding what the dark energy is. First, some people thought it was a fluke. Maybe the supernova people had gotten it wrong. But the amazing thing is now we have a completely independent way of measuring this stuff. Also, what we can do is first we can use Einstein's theory of gravity, which tells us that if space is flat, so that really big triangles have their angles add up to 180 degrees, then we know exactly how much stuff there must be. We know the total matter budget. And then we can go out and look at the galaxies and see how much stuff is there really, and we get only 25% of that. So there's got to be 75% of this other stuff, which is exactly the same number that the supernova measurements get.
How did you calculate that again? You used the geometry of space.
That's right, and that's one of the most profound things about Einstein's theory of general relativity, that there's a relation between how much stuff there is in space,
yes,
and the geometric shape of space, how curved it is.
Right.
So we measure the curvature, we know how much stuff. So the million-dollar question now is to see, is it constant? Because if it is, it's the big chill we're in for. If it's not constant, it's the big crunch or the big rip. So this is very exciting, because clearly we want to know the future of our universe. At the same time, though, we mustn't get hubris and say that's the future of the universe with capital T, because that's the future of our part of space here. If inflation really happened, and there are other regions like this as well, then that's just
lots of balloons all around the room.
Then that's just going to be the future of this patch. And there may well be other patches where this dark energy has a different value, which will have a different future. So I think that's probably the case, because that's the only explanation we have for why the dark energy density has such a bizarre value. The value is 10 to the power minus 123. So it's 1 divided by 1 with 123 zeros. And the only explanation I find the least bit compelling for this is that this is some kind of stuff which has a different density in different parts of space. And then it's no surprise that we happen to live in a place where that value allows the formation of galaxies.
Because if that were very different, there would be no galaxies.
If that were just a little bit different, if it were just 10 times bigger, you wouldn't make any galaxies here because the anti-gravity force would take over before the gravity had had time to pull the matter together in galaxies. That's exactly right.
Well, that is a unbelievable number. And to be so close to zero, but yet not zero, is astonishing. And the whole future is determined by it.
Exactly. So clearly, that's a number we would like to understand. So far, dark energy is just a code word for our ignorance.
Dark energy determines the fate of the universe. If more of it, all die by ice, expanding into oblivion. If less of it, all die by fire, crushed by immense gravity. Nice term, dark energy, as if physicists understood this stuff. From where did dark energy come? I follow the trail. I go to Lawrence Berkeley National Laboratory. I visit the scientist whose work revealed dark energy, Saul Perlmutter. Saul discovered that the expansion of the universe is not slowing down, but speeding up. It was one of the most shocking discoveries in the history of science.
Saul, theoretical physicists have taken the work that you've done showing that the universe's expansion is now accelerating and now predict a pretty dismal future, having lived with the data. How can you help us really understand what the far future, the far, far future, will be?
What we've seen is, of course, a surprising change from the earliest universe, when we think the universe was slowing down, to what apparently seems to be the last half of the life of the universe in which it's been speeding up. And since we don't understand exactly why that speed up is happening, it's a little bit difficult to extrapolate with confidence as to what will happen in the long, far future.
Everybody knows the universe is expanding. We thought the expansion would slow due to gravity. How has this expansion tracked?
So it looks as if the universe used to slow down.
When, for example?
And we think further back than about 7 billion years ago. So about half of the time back in history,
it was actually
slowing down. And we think it's because back then the universe was more dense. So basically, all the matter was closer to all the other matter, and gravity was stronger, therefore.
It was the same amount of matter in a smaller amount of space.
Exactly. And as the universe expanded, though, all the stuff in the universe became more and more dilute. Distances between all the particles in the universe became further and further, and all the objects in the universe. And so gravity becomes weaker, and we think that what's happening is that you're beginning to see, underneath it, there was always this dark energy trying to expand space. And it wasn't winning because gravity was so powerful. But once gravity becomes weak enough, it takes over.
Because this dark energy is in every bit of space.
Exactly. We think it pervades all of empty space. So the more
in the
empty
same
space,
amount. So
exactly.
The more space you have, the more absolute amount of this dark energy you have.
Exactly. And at that point, from then on, the universe will expand faster and faster. And of course, then the thing just builds on itself, because now the more you expand, the more of the dark energy you have relative to the mass. And so the more it wants to expand faster. In fact, since we don't know what causes the current acceleration, you could imagine that it will turn out to be a series of different new dark energies coming into play. Some might want you to speed up, some might want you to slow down. And that's the reason why you might not want to make a definitive prediction today as to what the fate of the universe will be at the end of the time, because we now know, which we didn't even know just a few years back, that you can have new things happening. And so if there's a new thing that happened 7 billion years ago, how do we know that there won't be another new thing that occurs in another 7 billion years?
So the open universe is still an open question?
In my mind, I think most people would say that we can't know yet.
Is dark energy the master of the fate of the universe? Will dark energy continue to increase and power an ever-quickening expansion into nothingness, ice, or somehow reverse, changing the future into a big crunch, fire? Either way, not so nice. But most cosmologists now believe that there are many universes, a multiverse, an infinity of universes. If so, then even if dark energy decimates our universe, it would not take down the whole of reality. But why postulate other universes which we cannot ever see? I go back to MIT to meet a pioneer of multiple universes, the discoverer of cosmic inflation, Alan Guth.
Alan, from your perspective, particularly in the context of inflation theory, which you created, how do you see the far, far future of the universe?
Inflation, in its simplest form, produces not just a single universe, but in fact an infinite number of universes. Inflation is a twist on the Big Bang Theory in which one proposes that in the early history of our universe, there was a period of exponential expansion that was driven because the universe at that time, we believe, was filled with a peculiar kind of material that literally turns gravity on its head and produces a gravitational repulsion instead of the usual gravitational attraction that we're accustomed to. This inflation would end because this repulsive gravity material is fundamentally unstable, so it decays like a radioactive substance decays. But it doesn't all end there. While it's decaying, it's also continuing to exponentially expand. Because of the exponential expansion that continues all this time, the half that did not decay would, at the end of this period, have a volume which is in fact much larger than everything that you started with. So at each stage, even while this repulsive gravity material is decaying, the volume of it just keeps getting larger and larger at, in fact, an incredibly rapid rate.
And once this process starts, it cannot be stopped?
As far as we can tell, it cannot be stopped.
So then maybe the question we have to ask bifurcates into two radically different questions. One is, what is the far future of our piece, which I think you call a pocket universe? It's a very big pocket, but it's a pocket universe. And then what is the far future of all that exists, that inflation is creating all these different multiple universes?
That's right.
Is that fair to do?
That's fair to do. So as far as the multiverse is concerned, as far as everything that exists is concerned, this picture of eternal inflation says that it will go on forever. And forever there will be regions that will be inflating. Those regions will decay in places. Each time a decay occurs, it will produce a pocket universe. And this will go on literally forever, producing an infinite number of pocket universes. And so in some ways that's a rosy picture because it goes on forever. The story for our pocket is much less rosy. Our pocket right now is undergoing accelerated expansion, and if that continues, then it will exponentially expand into the infinite future. As that happens, all of the matter in the universe would dilute due to this enormous expansion, and it does mean that ultimately life would die out in our pocket universe.
So even if our little pocket disappears, the plenitude of all reality is literally infinite.
That's right. That's right. There will be things going on in our universe, or at least our multiverse, literally forever in a volume which is essentially infinite.
An unfathomable multitude of pocket universes, each pocket vastly larger than all that we see in our universe. So that even if the future of our universe is decay into emptiness, there would be infinite new possibilities in an unending cosmos. The plenitude of all reality is so overwhelming. I am drained. It is just too much. But I remain restless. Always the far, far future of the universe, and its apparently certain end keeps nagging me. While attending a cosmology conference on a ship, I meet a cosmologist from Tufts who focuses on eternal inflation, Ken Olum. Ken did his PhD under Alan Guth, and suddenly I was back in the end game.
Ken, how many different ways can the universe end?
I'm sure there are many ways in which the universe could end. The simplest way, the way that's going to happen if there's nothing going on that we don't know about, is that everything will get very dark and cold. Eventually all the stars will use up their fuel and burn out. Eventually all the black holes will evaporate, the protons will decay. Nothing with any structure will be left. There won't be any possibility for life anymore because there won't be any energy, any free energy for people to live on. And there won't be really any chance for anything interesting to happen. So another possibility is that the universe will really come to an end in some way, a sharp end. What we think of as the vacuum, empty space, might not be the lowest energy state. It might be possible for it to decay into something else, some different kind of stuff, which would be very unlike what we have. After that decay, the universe would then collapse. And in any case, once the universe in which we live had decayed into something else, the laws of physics would be completely different. So suddenly, we would not be here anymore. This usual way that this might happen is through the nucleation of a bubble. So if you imagine that somewhere out in space, somehow a little bubble forms of something which is different and has a lower energy, this bubble might expand. It would expand at essentially the speed of light. When this bubble passed over us, we would cease to exist. So there's another.
And eventually that would just go through the whole universe.
Eventually the universe would be covered by bubbles like this. Nothing would be left except this other, whatever it was that was left behind.
Yeah. Now, is there a finite possibility of such a bubble occurring? If there is, then at some point it has to happen.
Well, there are two pieces to the question of the finite possibility of a bubble occurring. One is, does the right theory of cosmology, the right fundamental theory of physics really, allow the vacuum to decay into something else? And the answer to that is nobody knows.
Sure.
If it did allow it, then it would come with some finite probability. Therefore, eventually this would happen. So the universe would not go on forever, except that if the universe is expanding exponentially, the growth in the volume due to the expansion could be bigger forever than the loss of the volume due to the formation of the bubble of something else. So there'll be bubbles and bubbles and bubbles, and in the space between the bubbles, everything will keep expanding. Inside the bubble, probably it collapses. But in between the bubbles, everything expands. And so maybe half the universe is taken up by these growing bubbles, but the half which is left expands by 10 times. So there's more space now than there was before. So the universe could go on that way, even though any given point, you would expect eventually to be swallowed up by a bubble and come to an end. The total amount of leftover space, which is still just expanding and getting colder, would still grow forever. Of more interest, to me at least, is the possibility that new universes like ours could form as bubbles. And then this wouldn't allow us to continue on forever, but inside that bubble it would grow, it would become a whole new infinite universe of its own, and that universe would be full of people and everything else that can happen in a universe because it would be infinitely big. So people like us would come into existence again.
Would there be any possibility of the entirety of the universe? We're using it in loosely, but not just the one we're seated in, but the entire multiverse, all the universes coming to an end. Is that even possible?
Well, the general idea of the way that multiverses work, all possible things are happening. So collapsing universes that do come to an end are being produced, and expanding universes that don't come to an end are being produced. But, of course, the whole thing could be in a simulation. The entire multiverse could be simulated, and after a while, it's the end.
Well, yeah, but in that case, you have something else doing the simulation, and so that exists.
Right. So, of course, we know nothing about what kind of intelligent entity it would be that's built these big computers that do the simulation. There could also be all kinds of things. We don't know, and we never can know for certain, if the laws of physics that we have, our understanding of the universe, is the final understanding. There could be more to it. The universe could require some sort of stuff to exist, and after a while the stuff could run out. Or there could be laws of physics that we don't know anything about now that come into play only after a long period of time. So the question, will the universe ever come to an end, I don't think could ever be really definitively answered.
The end of our universe, ice or fire, seems inevitable. But who cares what happens in billions or trillions of years? Even such a dire future seems irrelevant to our mortal human lives, where living to 100 is a cause for celebration. I disagree. I feel deeply and daily that meaning and purpose, if any of it is real, must relate to reality, which includes if, how, and why the universe will end. But wishing for meaning and purpose must not drive cosmology. Cosmology is a young science, but its revelations are remarkable. Even if all things will ultimately end, new things will always begin. And I am taken by the plenitude of all reality. Destinies, I believe, provide parallel meaning with origins, because if origins can be promises, destinies can be fulfillments. But for me, simply wondering whether the universe will end is itself meaning, if not purpose, taking us closer to truth.
For complete interviews and for further information, please visit closertotruth.com.